Welcome to Continuity Quest, the show where we explore the threads that weave together science,
history,
and the unknown. Today's episode brings us to the bottom of the Pacific Ocean, into a world with no light, extreme pressure, and, until recently, no known source of life. What we've discovered down there has the power to reshape everything we understand about life on Earth, and potentially, life elsewhere in the universe. Let's dive in. Roughly 2.5 miles beneath the surface of the Pacific Ocean lies a region of total darkness. There is no sunlight, no plants, no photosynthesis. For decades, science assumed this was a biological dead zone. Nothing could possibly live in such hostile conditions. Then, something unexpected happened. Oxygen sensors placed at the seafloor began returning positive readings. Clear evidence of oxygen in a place where no photosynthesis could occur. At first, researchers thought their instruments had failed. They recalibrated, they repeated the measurements, but the results were consistent. Oxygen was being generated in total darkness. Not by sea life, not by plants, but by rocks. These weren't ordinary rocks. They were metallic, ancient, and strangely active. They emitted a steady electric current. It turns out they were generating enough voltage to split water molecules into hydrogen and oxygen. A process normally dependent on sunlight was occurring without it. This newly observed phenomenon was named dark oxygen. Oxygen produced in the absence of light, entirely driven by electrochemical reactions. The implications were profound. Suddenly, scientists had to re-examine everything from the origin of the Earth's atmosphere to the conditions necessary for life itself. If oxygen doesn't require sunlight, then perhaps neither does life. But as shocking as this discovery was, not everybody was surprised, because one organization had known about these rocks for decades: the Central Intelligence Agency. In the late 1960s, during the height of the Cold War, a Soviet submarine carrying nuclear missiles sank deep in the Pacific Ocean. The Soviets could not locate it, but the United States saw an opportunity. The CIA launched a covert operation, Project Azorian, to recover the submarine without alerting the world of its intentions. To mask the mission, the United States used a clever cover story: deep sea mining. With financial backing from billionaire Howard Hughes, they constructed the Glomar Explorer, a massive ship equipped for the operation. Publicly, the vessel was intended to collect mineral-rich rocks from the seafloor. Secretly, it was hunting for a sunken nuclear submarine. On March 8, 1974, the team located and began recovering the submarine. But in the process, they stumbled upon something unexpected: fields of strange, dark, and metallic rocks littering the ocean floor. These rocks, known as polymetallic nodules, looked like large marbles or softballs and were rich in metals like manganese, cobalt, and nickel. But there was something even more unusual. They were not inert. They were conducting electricity. Even though the CIA's primary goal was the submarine, the discovery of these nodules didn't go unnoticed. To maintain the cover, some scientific research into these nodules began. And it turned out they weren't just metallic anomalies. They were ancient power sources. A single nodule generates only 1 volt of electricity, but together, clustered in fields spanning hundreds of square miles, they form a vast natural battery. These nodules exist in huge numbers. It's estimated the Clarion-Clipperton Zone, the CCZ, alone contains over 21 billion tons of them. That could translate to tens of megawatts of naturally generated, low-level electricity across the ocean floor. This is not just theoretical. It has been measured. And in 2022, researchers discovered what the power can actually do. Marine biologist Andrew Sweetman and his team were studying the seafloor ecosystem in the CCZ when they recorded a sudden tripling of oxygen levels in just 2 days. The oxygen was being created via electrolysis, triggered by electrical fields from the nodules. No sunlight, no photosynthesis, just water, electricity, and ancient rock. It was the very first time oxygen production has been confirmed from natural electrochemical activity in complete darkness. The scientific world was stunned, but for the Pentagon, and especially the CIA, this was old news. For decades, research into these rocks had been classified. Why? Because of their potential. Polymetallic nodules are not just mineral deposits. They are electromagnetic conductors. Their properties could be harnessed for everything from advanced energy systems to military technology. Some speculative theories even suggest they may influence gravity or magnetism in ways we don't even yet fully understand. But even if you leave the fringe theories behind, what we know for sure is enough to change science forever. Electricity, water, oxygen. These three ingredients are foundational for life as we know it. And if the Earth's early oxygen didn't come from plants, or didn't only come from plants, then these rocks may have played a pivotal role in the evolution of life on this planet. Now shift your gaze upward, 390 million miles away, to Europa, the sixth moon of Jupiter. Covered in a thick crust of ice, Europa has long intrigued scientists. Beneath its frozen surface lies a massive global ocean, 100 miles deep, 10 times deeper than Earth's. Until recently, scientists doubted life could survive there. Without sunlight, there could be no oxygen, no photosynthesis. But the dark oxygen discovery changes that. Jupiter's intense gravity causes tidal flexing in Europa's core, generating heat through friction. That heat keeps its ocean liquid. Meanwhile, Jupiter's radiation bombards Europa's icy shell, causing radiolysis, the splitting of water molecules into hydrogen and oxygen. This process, combined with the potential for metallic nodules on the ocean floor, creates conditions strikingly similar to the CCZ. And in 2024, Russian scientists confirmed that radiation-induced oxygen formation does occur even in solid ice, proven in Antarctica. That means the same could happen right now on Europa. Okay, let's zoom out. Our galaxy contains an estimated 40 billion Earth-sized planets in the Goldilocks zone, regions around stars where the temperatures allow liquid water to exist. For decades, we focused our search for life there, assuming photosynthesis was essential. But with dark oxygen, we are no longer bound by sunlight. If life can arise in total darkness, powered by electrochemical reactions, then the number of potentially habitable worlds explodes from billions to trillions. That includes not just planets around stars, but moons, rogue planets, and even asteroids with underground oceans or frozen interiors. Anywhere electricity, water, and basic chemistry could coexist, life could emerge. Back on Earth, the story grows stranger. In 2023, researchers completed the most extensive survey ever of the Clarion-Clipperton Zone. They discovered over 5,000 unique species, 90% of which were completely new to science. Many of these species were found living directly on or near the nodules, but even more astonishing were the electrotrophs, microbes that don't consume organic matter. They consume electrons. These bacteria live by extracting energy directly from electrical currents. They've been found on shipwrecks, deep sea cables, and most abundantly, on the nodules themselves. This isn't just a new species. It's a new metabolism, a parallel path for life. While traditional life evolved to harness the sun's energy, these organisms evolved to harness electricity. It's an alternative biosphere, one we've only just begun to understand. Some scientists even believe the nodules aren't distributed randomly. They form patterns, organized, geometric layouts that resemble circuits or neural pathways. Satellite measurements have detected electromagnetic pulses originating from these zones, pulses that fluctuate with the Earth's magnetic field. This has led to the seafloor neural network theory, a controversial hypothesis that the nodules form a vast, natural electrical system. Some fringe researchers even speculate that it behaves like a primitive brain, a global-scale processor shaped over billions of years. Others point to navigational anomalies, like those in the Bermuda Triangle, as potential consequences of these undersea electromagnetic fields. Though mainstream science largely rejects these claims, the United States Navy has recorded real malfunctions in these regions, spinning compasses, disrupted communications, and failed electronics. Whether you believe the more far-fetched theories or not, the measurable electromagnetic activity is real, and of course, we are already tampering with it. Deep-sea mining companies have begun harvesting nodules from the ocean floor. The metals they contain, such as nickel and cobalt, amongst many others, are essential for batteries, electric vehicles, and renewable energy storage. Industry leaders argue that ocean mining is less destructive than land-based mining. No forests are cut down, no rivers are polluted, no communities displaced. But this isn't the full picture. Polymetallic nodules take millions of years to form. Just 1 centimeter can take up to 10 million years. And once removed, they cannot be replaced. Test sites from the 1970s still bear the scars. 50 years later, no meaningful regeneration has occurred. And there's another risk. If these rocks really do play a role in producing oxygen or regulating seafloor chemistry, disrupting them could alter the delicate balance of our oceans. In Earth's history, 5 mass extinction events have been linked to ocean chemistry changes, 2 of which were specifically caused by loss of oceanic oxygen. If we dismantle this undersea system before we understand it, we risk triggering an ecological cascade we cannot stop. Let's go ahead and review what we do know. Polymetallic nodules produce measurable electrical current. That electricity can split water molecules, creating oxygen without light. This process has been verified in lab experiments and field data. The nodules support ecosystems containing thousands of undiscovered species. Some microbes living on them feed directly on electric charge. These fields of nodules exist in structured networks across vast regions of the Pacific seafloor. But here's what we don't know. Did dark oxygen contribute to the Earth's atmosphere originally? Could these rocks be essential to maintaining global ocean health? What happens if we harvest them faster than ecosystems can adapt? And what if similar rocks exist across the universe, quietly shaping life we've never imagined? If dark oxygen is real, and it is, it forces us to expand our definition of life and habitability. Not just here, but everywhere. So often we've searched the stars for reflections of ourselves, blue planets bathed in sunlight, but perhaps we've been looking in all of the wrong places. Maybe life hides in the darkness, not just enduring, but thriving. Thank you for joining this episode of Continuity Quest. If this sparked your curiosity, share the show, leave a review, and subscribe for more explorations into the threads of science, mystery, and human continuity. Until next time, stay curious, stay aware, and remember, the truth is often buried deep